Imagine a planet where winds scream at 70,000 kilometers per hour, carrying vaporized iron and titanium through the atmosphere. Where one side is hot enough to melt steel while the other remains shrouded in eternal darkness. Where the weather is so extreme that scientists say it feels like science fiction. This planet exists. It's called WASP-121b, or Tylos, and astronomers just created the first ever 3D map of its atmosphere. What they found defies everything we thought we knew about planetary weather. 900 light-years from Earth, in the constellation Puppis, orbits one of the strangest worlds ever discovered. Using the European Southern Observatory's Very Large Telescope in Chile, astronomers combined the light from all 4 telescope units to observe this planet as it passed in front of its host star. As starlight filtered through the planet's atmosphere during this transit, it carried chemical fingerprints, signatures of elements present in the alien air. The espresso instrument detected iron, sodium, hydrogen, and even titanium. These elements acted as tracers, allowing scientists to map winds across 3 distinct atmospheric layers for the first time ever on any exoplanet. Lead researcher Julia Victoria Seidel from the European Southern Observatory describes the discovery. This planet's atmosphere behaves in ways that challenge our understanding of how weather works, not just on Earth, but on all planets. It feels like something out of science fiction. WASP-121b, nicknamed Tylos, is an ultra-hot Jupiter, a gas giant that orbits its host star so tightly that a complete year there lasts just 30 Earth hours. That's right, this planet completes an entire orbit in less than 2 days. Like our moon with Earth, Tylos is tidally locked to its star. One hemisphere perpetually faces the blazing sun, while the other remains in eternal night. The day side reaches temperatures up to 2,500 degrees Celsius, hot enough to vaporize metals like iron and titanium. This creates one of the most extreme temperature differences in the known universe. On one side, metals boil into vapor. On the other, those same metals would condense. This temperature gradient drives something truly extraordinary, the most violent weather ever observed on any planet. The 3D atmospheric map reveals 3 layers, each with its own composition and wind patterns. At the bottom, iron winds rage through the lower atmosphere. Above that, a sodium jet stream races around the planet's equator. And at the top, hydrogen winds complete the picture. The numbers are staggering. The jet stream around Tylos' equator reaches speeds of 70,000 kilometers per hour. To put that in perspective, that's about 19 kilometers per second, nearly double the fastest winds previously recorded on any exoplanet. Earth's strongest hurricanes reach about 300 kilometers per hour. Jupiter's Great Red Spot, the most powerful storm in our solar system, generates winds of 450 kilometers per hour. Tylos' winds are over 150 times faster. As Seidel notes, even the strongest hurricanes in the solar system seem calm in comparison. But here's what makes this truly bizarre. The jet stream spans half the planet, rotating material around the equator in a massive circular current. Meanwhile, a completely separate wind system at lower atmospheric levels moves gas from the scorching day side to the cooler night side. Seidel explains, "What we found was surprising. A jet stream rotates material around the planet's equator, while a separate flow at lower levels moves gas from the hot side to the cooler side. This kind of climate has never been seen before on any planet. Imagine those winds carrying clouds of vaporized iron and titanium. On the day side, these metals evaporate into the atmosphere. The winds sweep them across to the night side, where cooler temperatures cause them to condense, potentially raining molten metal onto the planet below. What makes Tylos even stranger is that its weather system operates in reverse from what theory predicts. On planets in our solar system, jet streams form from internal temperature differences. Warm equators and cold poles create circulation patterns we understand well. But Tylos' jet stream appears to be driven by its star's intense external heating and possibly its magnetic field. As Seidel puts it, what we see now is actually exactly the inverse of what comes out of theory. This planet is literally rewriting the rules of planetary meteorology. Bibiana Prinoth, a PhD student at Lund University who led a companion study, captures the significance. It's truly mind-blowing that we're able to study details like the chemical makeup and weather patterns of a planet at such a vast distance. This experience makes me feel like we're on the verge of uncovering incredible things we can only dream about now. The Very Large Telescope has proven it can map the atmospheres of hot Jupiters like Tylos, but smaller, Earth-like planets remain out of reach for now. The next generation of telescopes, like the extremely large telescope currently under construction in Chile's Atacama Desert, will change that. With its 39-meter mirror and advanced instruments, the ELT will be able to probe the atmospheres of rocky exoplanets similar to Earth. This means we'll soon be able to search for signs of habitability, water vapor, oxygen, methane, or even potential biosignatures that could indicate life on distant worlds. WASP-121b isn't just a strange exoplanet. It's a laboratory for understanding planetary physics in the extreme. From iron rain to 70,000 km/h winds, from inverted atmospheric physics to weather that defies our models. This world 900 light-years away is teaching us that the universe is far stranger and more diverse than we ever imagined. And somewhere out there, right now, those savage winds are still howling through the darkness, carrying clouds of vaporized metal across an atmosphere we're only beginning to understand.